Okay, this is what we have so far from the last time. I don't even remember what this is. Oh yeah. Okay, where are we? Okay, we create the index map flip. So now we need to create other index map functions and work our way up to convolution. Okay, we have flip. Now we're gonna try other ones. What else? What else is there? Flip, rotate. No, rotate is complicated. Let's try something simpler. Uh, rotate, shift. Okay, shift. They're all basically the same thing. Just copy and paste. Okay, shift. Shift just moves the image by a given value. Just move the image by a given value. Long A. But now we need to know what X is. Everything else stays is exactly the same. We don't need to worry about any of it. We don't even need to check if parent is right because it just won't work. Okay, everything else here stays exactly the same except we change the X, Y, Z to something else. Okay, but now we have to decide what it should be. Okay, X, shift. Okay, X equal long. Oh wait, what am I doing here? What is it doing? Long X, long. Okay, I minus A. We just move the X by a given value. J minus B. Okay, long. K minus C. And otherwise, it's exactly the same thing. Everything else is exactly the same. We just change the X values for something else. Shift. Let's copy it up here. Xmap git shift. We can even combine them actually. Shift. Okay, where are we? Okay, source. Change it from flip to shift. Shift by how much? Okay, random. Okay, shift by a random value. Okay, random. Wait a minute. Wait, what are we doing? Okay, shift by. I don't even know where I am. Okay, shift by random value. Okay, 20. Let's just say 20 minus random. Random 40. Okay, it's the double one. Random. Oh wait, is it 5 or yeah? Oh, I hate this thing. 20 minus random 40. Okay, now here's a problem. We keep having to move everything by random amounts. Type sequence shuffle. We create it and then we have to destroy it. This is gonna be slow. Okay, we have to destroy it afterwards. Index map, destroy. Create then destroy, and this is just going to slow everything down, but doesn't really matter. Type index map destroy and index map. This is the first time we're going to use destroy by a lot. Create it and then destroy it. Okay, for I. Oh, what am I doing here? I don't need K. I was wondering why this is here. Index of I. So we don't need K here. Just a house keeping stuff. Okay, for each. Why is it shifted? I don't know. Okay. Okay, save everything. Is it good? Index map. Build, rebuild. Okay, let's run it, see what happens. Oh, it's shifting, but it's shifting by the same amount, so we can't really see it. We can't really see by how much it's shifting. Okay, let's try that again. Okay, this time you're gonna shift inside the loop. We're gonna create one for each image and then destroy it after each image, which is just going to be very, very slow, but we don't care. Okay, edit, advance, format document. Okay, this is just going to slow everything down a lot. I'm probably not going to need sleep. Okay, just comment that out and see what happens. Build it. Oh, actually, we do need sleep. It's too fast. Thought it was going to be slow, but it's actually very fast. Okay, try it again. Ah, there it is. It's shifting the image by random amounts. It still doesn't look that great, but let's do the shifting by even more, just to make it very, very obvious. Okay, 40 minus 80. 40 minus 80 by random 80. Okay, let's move even more. Okay, it's more obvious this way. It just keeps shifting the image back and forth. Moves it up and down, side to side. Yeah, it doesn't look very good, but it demonstrates everything. So let's do something more. Okay, so we're going from shift over to what else is there? Copy and paste. This one should be more complicated. Shift and zoom. Zoom's a favorite. How do we do a zoom? Okay, for zoom we need to find the center of the image. Okay, XC. We need to find the center of the image. YCZC. Or for zooming. Okay, XC equals. Is it double or? Oh yeah, it has to be doubled. Okay, it has to be double because otherwise we need to precision. Double result dot shape width. YC shape height, ZC shape depth. Shape depth. X, Y, and Z. That's the center of the image. We have to calculate the center of the image. And for each pixel, oh no, divide by 2. What am I doing? We have to divide by 2. And you're gonna know to get the center. Okay. Okay, what else will you do? Zoom. In order to get the center, we have to zoom and okay. Zoom by a certain amount. Okay, x equals long I minus xc to get the distance from the center, distance from the that pixel's distance from the center times something times a minus xc. Not a the zoom value a plus xc. Okay, why is that? We the zoom value is wait, the zoom value is a ratio. It's not actual value, so it has to be double. It has to be double. Yeah, it's a ratio from 0 to 1. Well, actually, it could be more than 1. It's a ratio. Okay, x minus xc. Okay, I minus xc times a minus xc. So we calculate distance from the center. Okay, calculate the distance from the center and multiply it by 8 times xc. 8 times the value from the center, the absolute value from the center. Not the absolute value. We multiply for the value in order to push it out or pull it in. Okay, it's like a ray. You have to make it longer or shorter, to zoom in or zoom out. Okay, y, z, a, b, c, b, c. Okay, a, not x, not x, y. Distance from the center and zoom out toward the center. Okay, and cast it back to long. Okay, ijk, everything's the same. Why is x? Because now we need to consider this because it might go outside of the screen. So it has to be long. Assigned variable. It has to be a signed variable. Okay, now for zooming in. Yeah, I think that's it. Unless I'm missing something. Okay, we cast it. Yeah, it's good, I think. Okay. Index map zoom. Okay, let's copy them because I don't want to have to retype this every single time. Index map zoom. Okay, zoom. We have to cast it out in a value. 0.5 is good one, plus double a random value. Let's pick a random value here. Rand and 10 rand 10 divided by 10. Why do we do this? So that we have a value between 0.5 and 1.5. We don't zoom at all. Set that to 0. It has to be 0, I think. Yeah. We need a value between 0.5 and 1.5. This is going to tell us how to zoom here. Okay, do we copy everything right? Yeah, let's see if it works. Oops, missing something. We missed something. I made a mistake somewhere here. Oh, right here. Oh, this is one of those really, really complicated mistakes that you can never find. Okay. Okay, we have to cast everything into. You have to do the entire operation as a floating point value. Otherwise, we'll risk losing data. Okay, get rid of that, and get rid of that. Okay, so the whole thing has to be casted as a floating point operation. Otherwise, it doesn't work at all. Okay, let's see if it works now. Okay, there it is. Okay, it's kind of weird. Okay, it zooms different ratios, but okay, let's try something else. Instead of zooming at different ratios, we zoom at the same ratio, double. No, double R equals whatever this is. We need to make everything even. Okay, R 0. Make everything even just so it zooms in more consistently. Okay, now let's zoom. Okay, this is better. It zooms in and out. Okay, zoom in and out. Okay, if we want to do a data augmentation, this is very good. Well, it looks good. Okay, now for the big one. Well, the second big one, rotation. Okay, now we copy it to do rotation. I've copy and pasted from zoom, and then we do rotation. Now I need to remember how do we do rotation here. Let me check. Okay, the rotation cannot be a 3D rotation because that would just be too complicated. So instead we do a 2D rotation. Okay, now we need the angle. Unlike the ABC, not angle, we just need to know the angle of the rotation. So we don't use IJK, we just use I and J. But that does make everything more complicated because, well, maybe it doesn't. Okay, how do we do the resultant x? We need the x center again. No. Actually, x center equals x center, okay. X center, y center, x sine. The sine equals, oh, now we have to define the sines. We do that later, okay. Type def. Okay, I've done this before. Okay, now we need to define sine and cosine. Okay, I've done this before here. Const. Okay, we need to find pi. And then that just copying from Mat library. Define sine and cosine. That's before and I remember it. Okay. X sine. We got type sine angle. Okay. The sine of the angle. Okay. X cos equals type cosine. Okay, I'm just gonna have to figure this out here because it's gonna take a little while. Okay. Now we need to define sine cosine double x sine x cosine. Okay. XC, we don't need that. Okay, x cosine, x sine, and cosine. IJK. X equals, okay, we have to, cosine is, I have to remember how to do this. Okay, x, d, we need the center. The distance from the center. XD equals, the distance from the center, I minus XC, X center. J, not Y, D equals J times YC. Okay, K, not Z, not ZT. We don't need a ZT. I don't think we need a ZT. But we still have to calculate the X, Y, and Z values. Okay. Okay, X, Y, and Z. Okay, so this is gonna get complicated here. To make things simple, we're just gonna skip everything because if we have to use this, we just have to specify that the Z value is not specified. Okay, get rid of K. Okay, get rid of Z and set that to 0. Okay, in this special case, we're not going to be doing using the third dimension because that's just be too complicated. Okay, let's see. To do the rotations xt, let me look it up on Wikipedia one moment. Okay, image rotation. I didn't find it on Wikipedia, but I found it somewhere else. Okay, image rotation. Okay, image rotation is xt from the center times x cosine plus xt times x sine. Okay, plus xc plus x center. Okay, so okay, we have to cast everything, right? Otherwise creates a problem. Okay, this one's similar but not quite the same. Okay, long yt times x cosine, no, not x cosine, is it x cosine? Yeah, x cosine minus xt. Oh, I made a mistake here. It's yt. It's yt here, xt here. It's the reverse. X sine plus y center. Yc is the y center, xt. Everything else is the same, so that should do it. Rotate 2D. Everything else is the same for the image. Okay, so I hope we didn't miss anything. Width, height, xc, angle. Yeah, that should do it. Rotate 2D, which is different from rotate 1D. Count expression. Okay. We define pi as a constant. We don't need that many digits, but it was there, so I used it. Okay, type index map, create rotate, rotate 2D. Ah, okay, now we have to move this back outside. Okay, double R equals 0. Okay, we have to move this back outside because they're all going to be rotating at the same amount. R plus plus. Should it be plus plus or plus some different value? I will see. It doesn't matter. Shape rotate. No, R, not R. It's just one R. One R double. That's the angle. It's from 0 to 360, not in radians. Okay, I forgot to specify this. Index map. When you do the sine, we have to convert it into radians. Otherwise, it doesn't do the 360. So it's just harder to comprehend if we don't do that. Angle divided by 180 times pi. That converts it from radians from angles into radians. So the sine function only understands radians, but I operate in angles. So let's see if it works. Oh no, it didn't work. I have to correct a few things. Fine. Okay, we're having a lot of trouble with the angles thing. Let's create a new module to deal with mathematics stuff. New file. Header. Type math. Not if and def. If and def. Type math. .h. All the mathematical functions go here. Define. Type math. And if. Type math. Okay, let's just move all the mathematical stuff here up here. Cut. And then just put it here. Okay, there was something else in bitmap. Where's bitmap? Okay, type bitmap, open bitmap. Okay, there was something right here. Where was it? I don't remember it. Oh no, it's not here. Oh, we don't need it. Okay, save. Type math. .h. Okay, close it. And type index map. And then include it. Type shape. Type math. And also, before I forget, what was it? Rotate 2D. Okay, we need xt. Okay, it's giving us several errors here. Xt. No. Xt. Yt. T is the distance from the center. Xt equals identifier not found, all sorts of stuff. Save. No, I mean save. Oh, build. Rebuild. Okay, it succeeded. Let's see. Huh. Something's not right. Okay, that was stupid. R belongs outside, not inside. If you put it inside, it's just going to reset to 0 every single time. Okay, let's try this again. Nope. Oh, it still doesn't work. Yeah, it turned out it actually worked. It's just that the sleep made it seem very slow. And also, we're not supposed to shuffle. Do not shuffle. And because we need to see it rotating. So let's try it again. Yes, we build. Ah, it's working. Image is rotating. Good. So far, so good. The image is rotating, rotating, rotating. We can do it backwards and forwards. So that means it works. Okay, that's enough for today. Next time, we're going to do convolution. And it's going to be the toughest one of all. Also scaling. Scaling and convolution.